How is it that your projects seem to finish about 2 weeks faster than ours do? Is the cadence flow that much better? Or do you just have a bunch of hotshots on your team?
I won't deny that we have a great team, but they really started firing on all cylinders with the cadence tools and the front-to-back methodology that promotes collaboration across the design team. The team-based approach has saved us a lot of time. For example, as our power integrity challenges increased, due to lower voltages, design density, and increasing number of power rails, we were able to avoid the PI engineer bottleneck at the end of the design cycle by adjusting our methodology to address power integrity by multiple team members throughout the design cycle.
I want to hear more about this. Our design teams have been using tools from various companies and have put together a methodology that has been in place for almost a decade. At one point, we were pretty sure we had a leading-edge approach.
Well, a lot has changed in 10 years. As our products became more sophisticated, the Cadence toolset improved and grew with us. Lately, we have really been excited to bring their power integrity tools in as early as the logical design stage. So when in the design process do you begin the power integrity process?
Well, we need the physical PDN to use our PI tools, so we don't get started until the layout is well underway.
We used to be in the same boat. No analysis until the design was done, and the PI guy and the layout guy would go back and forth for days and sometimes even weeks. That has all changed now. We actually start PI with a schematic. Take a walk with me. I was about to check on my team. We can start with Dave, and he can show you how we get started with the power integrity analysis early and the benefits it brings later in the design cycle. Hey Dave, sorry to bother you, but I'm hoping you can show Ken here how we've distributed some of the power integrity work to the design engineers while they are capturing the schematic.
No problem, Naomi. I was just making some updates to the latest revision on our Mount Rushmore project.
I heard about that change. You guys are adding in some of the latest FPGA technology. That's got to be a bit challenging given the high pin counts and all the decoupling capacitors that are going to be required.
For decap selection, our methodology starts with the Power Feasibility Editor, as Dave is showing now. It has a simple workflow and allows us to take our PCB stackup into account as we look at different capacitor strategies to meet the target impedance constraints defined by our vendors.
Yeah, the setup is straightforward, and I even use the same component browser and corporate libraries that I do for the schematics, so there's no guessing as to whether or not the cap can even be used or not. The whole process is more accurate and efficient than rules of thumb. The analysis includes the cap's loop inductance to help us determine if we should place them on the top or bottom of the board. The results of the analysis can be compared to the previous run as well as the target impedance, and we can even see what it looks like with no caps at all. Each decap strategy is captured in a template called a PIC set. It identifies the caps and the constraints for which side of the board they should be placed.
That sounds like it will be useful later on in the design cycle.
That's right. You guys should visit Dennis, and he can show you. We can also reuse the PIC sets when the same parts are reused in another design. But the best part is that I'm no longer getting those looks from the PI expert late in the design process regarding how I over-designed the decap strategy. All that's left to do is to put the caps in the schematic. It can be any page because the constraints associate the caps with the component.
I can see some of the reasons you're getting your boards out faster than us. We've been guilty of spending too much time late in the design cycle trying to evaluate our decoupling scheme, trying to add more where there is no room where we need to add them. We have missed deadlines having to reroute sections of the design to make room for the extra decaps.
I know that feeling. Management is hounding you to send out the design to manufacturing, but you know if you don't solve the decap problem now, it's going to cause a respin. It is the old pay me now or pay me later dilemma. That can cause sleepless nights. Well, one way we've been able to stay on schedule is through design reuse. Once we've got a design working and need to use the components on another design, we could just reuse the PIC sets. Both our design engineers and our power integrity engineers have confidence in the strategy since it has already been used before, and I'm happy since I know we've optimized the design for both cost and performance.
Thanks for the time, Dave. Naomi, I hope you don't mind if I connect Dave with some of the key design engineers on my team. I'd like them to come up to speed on this methodology.
We'll make the time. We're happy to share the techniques we've used to modernize our PCB design flow.
Thanks for showing me how to get started on PI at the schematic stage. I was thinking, and I guess we do have some work we do early. We do sit down and do a design review of the power delivery network from the schematic data.
Let me guess, with spreadsheets?
Sometimes, but sometimes the guys just draw it all out on the whiteboard using the schematic as a guide. Wait, don't tell me you have a tool for that. Those spreadsheets and drawings can really become tedious, especially when we are on revision 9 of a schematic.
I really need to introduce you to PowerTree. We get a graphical view of all the power topologies sourced to sinks. It gets produced directly from the netlist. And when we are on revision 9, it is a piece of cake to compare it to version 8. Not only does PowerTree save us review time, it has cut out a lot of frustration. The team used to cringe when a new rev of schematic would come out, but not anymore. It takes seconds to generate a new tree, which can be automatically compared to the previous versions and highlight any differences. Even better, all of the setup information can be transferred from the old tree to the new tree with the push of a button.
That sounds amazing, but we still use our spreadsheets to do power estimation. I'm assuming that does not change, right?
This might surprise you, but we can throw away those spreadsheets. The DC analysis in PowerTree can actually simulate everything for you.
Are you telling me that you run DC analysis pre-layout without any copper? I don't get it.
The DC analysis in PowerTree is primarily used to verify all of the models are correct. Since we assign them up front in the process and don't want to wait to find a model problem later in the post-layout analysis. All the models are stored in a library, and the Analysis Model Manager makes it easy to reuse those libraries. For newer components, we add them into the library and include pin-based electrical constraints. Aside from model verification, the analysis occasionally finds a real problem even without any loss from copper. For example, we just used PowerTree the other day to find a problem with inductors we used. They all had the wrong current rating. We caught it early, made changes to the schematic, and that's one less problem we have to deal with later on.
We wouldn't find that until, hey, wait, we might have that same problem on the Mount McKinley project and not even know it yet. We are already up against the wall with respect to the schedule. I can't imagine the delays that would cause if we find a problem like that just before sign-off. Do you think we can run PowerTree on our design?
Sure, we can help you out there. Your schematic tools will be able to create a Cadence netlist. Just send the netlist over to Sam and he will do a quick check for you. I don't want you losing any more sleep over that project.
We've relied on our PI experts to validate that our PowerNet components are all properly rated for the designated power rail. But they are busy and they are human. I really like that you have a method of checking this early and that multiple members of your team can keep an eye on the power topologies as the schematic evolves. Thanks for volunteering, Sam. I'll make sure that our team learns this technique so we don't have to rely on Sam in the future.
Sounds good. I think you'll be really happy with PowerTree. We've gotten to the point that when we release our schematics for layout, we have a high confidence that all the power topologies are correct and all our major components are properly decoupled. All our AC simulations are set with target impedance constraints, and all our DC simulations are set up with sync information with maximum IR drop constraints. And now that we know we can simply push a button and run analysis pre-route, we simply need to apply the PowerTree to the design as it is being physically implemented, and we can run simulations on the physical design also with a push of a button.
Wow, it seems like we always have that awkward time when layout is complete, but it takes about a week to get our simulations running. We've tried to shorten that time, but I can see how PowerTree is going to make that handoff go much smoother.
You're right about the handoff for post-route analysis, but it is even better than that. Pass-fail criteria has been put in place so that the PCB designers are able to run first-order PI analysis as they design the power delivery network. When they see results that indicate a failing condition early on in the layout process, it can be immediately corrected, and the power integrity experts never have to see those sorts of basic problems. Effectively, we are enabling the PCB designer to find and fix first-order power integrity problems without becoming a power integrity expert. You can imagine how much more efficient our design process has become when we reduce the number of iterations between the layout and analysis.
I don't know what to say. I had no idea that we could perform in-design PI analysis. I can see how this will make our PCB designers feel more valuable and our power integrity engineers less burdened. Definitely a win-win.
I think I see some Cadence training classes in your team's future.
Not so fast. It seems like we could just use PowerTree in our existing flow, couldn't we?
Maybe, but I have more to show you before you go down that path. I think you will really like how PI C-sets, PowerTree, and the decoupling capacitor placement add to InDesign analysis capabilities to make our PCB designer's life easier. Let me see if we can look over Dennis's shoulder while he works on the Mount Everest project.
That would be great. If I like what I see, maybe we can look at changing our flow for the upcoming Mount Fuji project. I know the schedule will be tight on that one.
Dennis, I hope you don't mind if we watch you while you work. I'm bringing Ken up to speed on how you're now able to get feedback on your PDN design as you design your PCB.
No problem. I heard you were talking to Dave and he gave me a heads up that you two might drop by. Before I show you how the InDesign analysis helps improve my design quality, let me show you how I use the PIC sets that Dave created. As soon as I place an IC, I know exactly how many decaps are to be placed with that device. Each decap I grab to place shows me the region where placement will be effective, and I'm guided on whether I should place on the top or bottom of the board. I remember having to read through the notes of the schematic hoping to find information on which caps went with which components. And then I was always placing the caps as close as possible, but that sometimes clogged up my routing channels. Now I know my limits. Of course, I still place the decaps as close as possible, but now if I need to pull a decap back from a component, I'm aware of how far I can go and still have a useful decap. I always felt a little foolish when the PI guy came to me and said I made his decaps ineffective. It's been a long time since I've heard that lecture thanks to the power integrity constraint sets.
I think I'm starting to get the picture. This technology from Cadence really does all work together seamlessly in a front-to-back flow.
It does work together nicely, but old habits sometimes die slowly. I know Dennis still likes his favorite PI guy, Sam, to run the first analysis. Sam simply applies the power tree in his PI tool. He ensures all the models are indeed set up properly, and then Dennis can take it from there.
Yes, I know our design engineers have good intentions when they set up the power tree, but when it comes to power integrity, Sam's the best. Any new power integrity models that were added to our AMM library can be verified by Sam and are then available for all of us to reuse every time we perform an analysis. I just feel better knowing that Sam has blessed the power tree and run through the first simulation. And since he knows I will be able to run fairly independently after that, he typically doesn't mind taking the time, even if he is working on another project, which he always is.
By independently, I guess you mean you can run InDesign PI analysis?
Exactly. It is up to Dennis. With PowerTree, he can run DC analysis and perform AC checks like target impedance. With PowerTree, he can run the analysis as many times as he wants throughout his design process. When he hands the design off to Sam, there is typically no more than 1 or 2 iterations between them.
Only 2 iterations? You've got to be kidding me. I can't tell you how many times, after 6 or more iterations, I've had to have the PI guy sit with the PCB designer to hammer out the final design. We've spent a lot of late nights and even weekends trying to get it right. And even then, we've had our problems with our prototypes. How exactly is it that the layout guy can read these power integrity reports?
The report files are HTML and are full of hyperlinks. When I click on an electrical violation, it takes me directly to the spot in my PCB design tool where I need to make changes. I'm still learning, so I don't always make the right change. But since I can just rerun the analysis, I can see if my change made things better or worse. In the end, Sam is usually pretty happy with the decisions I have made.
Wow, sounds a lot better than what we have been doing. I can see that we have a lot of idle time waiting for reports and databases to go back and forth, or inefficient use of time when 2 guys have to sit together and work over the same screen.
Our layout guys really take pride in fixing as much as they can. PI sign-off hardly ever finds simple errors anymore. The loop inductance workflows in the AC analysis tool are very easy to run, and the target impedance workflow uses everything that was set up in the power tree. DC analysis easily identifies IR drop problems. PCB designers can now detect when a component is being starved of power and either add vias or remove choke points. As much as we challenge these guys with our dense designs, they know they have to deliver power to the components, and in-design analysis gives them an opportunity to see if they have removed too much of the power plane. It is really cool to see how the whole team has stepped up to enable the next level of complexity we have in these new projects.
I can see that it's going to make sense to train our PCB designers on Cadence tools. This InDesign PI analysis is just too good to pass up. But I'll be honest, I highly doubt that our PI guys are going to want to change their tools to Cadence. They are satisfied with their existing flow, and we've heard the Cadence Sigrity tools are not user-friendly.
I appreciate the importance of usability, but inaccurate results that are easy to get are really not useful at all. There's a reason that Cadence has power integrity success stories all over their website from companies like Seagate, Bose, Lattice, Cisco, and others. I've looked for the success stories on those easy-to-use tools, and I just can't find them. We trust Sigrity, and I assure you that when we factor in the integration between Cadence design and analysis tools, any perceived usability advantage with other tools quickly disappears. Let's go talk to Sam. Hi Sam, this is Ken. He is my counterpart over on the Mount McKinley project. We've been going over how we use Cadence to manage our power integrity concerns across the design team. He's bought into the InDesign analysis, but he still thinks his PI team is going to want to stick with those easy-to-use tools.
I understand. With us power integrity engineers, tools are like religion. We typically don't want to switch to the new shiny feature in the tool of the day. We know our tool of choice will have that feature in the next version.
Exactly. And my guys just like the usability of their point tools. There's no change in that.
You might be right, but maybe I should talk to them. I switched to Sigrity for 3 reasons. First, the tools are accurate. I've done my own correlation studies, but I've also seen other Cadence customers. Bose, for example, they have presented papers showing just how accurate the Cadence power integrity tools are. But even if the other tools could match in accuracy, there is no beating the value of integration. We launch our PI tools directly from the layout environment. The PI models are stored with other analysis models in the Analysis Model Manager, and when I find changes I need made to the design, it is quick and easy to communicate those changes back to my PCB designer. Oh, and did I mention these tools are the most feature-rich power integrity tools on the market? So when it comes to accuracy, integration, and functionality, it really is no contest, in my opinion. The Cadence Allegro Sigrity front-to-back power integrity flow is the only way to go.
Okay, I'm coming around, but help me out. I'm sure my team thinks their tools are accurate, and I can see how they might be working around the integration pieces you mentioned. But can you tell me more about the feature set? They may not know what they are missing.
Oh, now you've done it. Sam can go on and on about this. You better pull up a chair.
Thanks, Naomi. Actually, it's easier to highlight our PDN methodology. When I get a design from Dennis, I have 3 main items on my PDN checklist. First is comprehensive DC analysis. IR drop analysis checks all sync power pins to ensure the required voltage is being delivered to the components. Dennis has already ensured that we meet IR drop constraints, but sometimes I see additional ways to further reduce IR drop or even optimize sense line locations, all of which provide greater margin. DC analysis also ensures that all PDN geometries meet reliability metrics for temperature rise and current densities. These constraints are checked automatically because it's practically impossible to visually inspect all the routing. This means we have more robust products in the field. My second PDN checklist item is decoupling capacitor optimization. Dennis has already met the target impedance constraints at this stage, but quite often I'm able to find ways to remove decoupling capacitors or make selective decap changes. This optimization simultaneously improves performance and reduces overall product cost. And finally, my third PDN checklist item is EMI analysis. Quiet power planes require low impedance across all of the PDN. By placing specific EMI decaps at the best locations, we drastically reduce power plane resonances, improve signal integrity, and reduce emissions. Anything we can do to get us through the government compliance tests the first time is a win for all of us. All these features are available to me in the Cadence Power Integrity Flow, but I think you will find many of these customized workflows are not available in other tools. Some of the decap changes are merely part updates, which back annotate easily. But some changes actually add capsand because we use the Analysis Model Manager. My model-based additions are already mapped to a real component. This means any BOM changes are easily communicated back to my PCB designer. Dennis and I work together really well with this integrated methodology.
And once those changes are communicated back to Dennis, he can then communicate any component changes back to Dave so that our schematics and bill of materials are all in sync.
Yeah, we go through the same process, but email, spreadsheets, and a lot of manual review is required. We're pretty good at it, but sometimes mistakes sneak through. Okay, I'm definitely convinced. I need to have a team meeting. We need to take a serious look at switching our toolset for the Mount Fuji project.
We'll be here to help you through the transition. I'm very confident that it will be a good move for our company when we are all on a Cadence front-to-back PCB design and analysis flow.